Tam na Slack? Je to Slack?
.NET.
Už vysíláme?
Už vysíláme.
Is it on? Is it on?
A myslím, že by i mě mělo být slyšet, když tady je zase líp. Můžete to někdo ověřit na Slacku, jestli to je v tom záznamu slyšet?
Já ještě to na Slack nedal.
Neohříval to bez zvuku celou dobu?
Třeba obecenstvo hodně.
Maličku z toho minula taky vysílal, nebo ne?
Ne, mi to může... Já jsem říkal HRkám, jestli chcou, ať to i Lučce, tak myslím si, že jako kdo to bude vysílat, protože já to nedávám, nevím, jak to nastavit a nebaví mě to.
OK, tak jdem na to. Tak ahoj, já jsem Jakub Pereš, mě všichni znáte. A dneska tady budu mluvit o Reflection v .NETu. Nebudu se moc zabývat Reflection obecně, protože je to taková hodně zajímavá myšlenka, ale pro nás jsou hlavně English. Okay. So today I will be talking about reflection in .NET. Sorry, I forgot you're here. And if we look at Wikipedia, what does it say about reflection? It says that it's the ability of computer program to examine, introspect, and modify its own structure and behavior at runtime, which sounds very fancy. Basically, what it means is that you can write code that writes another code, or you can write code that looks at a code and based on that does something or writes another code, or you just look at the properties of what you got and you work with it. So it's basically like you would be looking in a mirror and doing surgery on your own stomach. That's kind of why it's called reflection.
Sounds great.
Yeah, so sounds like fun, right?
Even the opposite side.
Not that much fun for me. I wouldn't want to try it. So for us, there are two gateways that we can use to get to the reflection stuff. I cannot put it on full screen because then I would be sharing my screen and I don't know how to set it up in Hangouts.
Okay,
it sucks. So the first gateway that we have is the system type that we will get back every time we call getType on an object. So every class that derives from object, which is every class in .NET, has this getType method on it. And if we call the getType method, we will get an instance of system type, or to be more precise, we will get an instance of system runtime type, which implements this system type abstract class. And this one has a lot of methods on it that we can use to look at the code through the reflection. And the actual behavior is then implemented in the system.reflection namespace and its sub namespaces. So we won't see the namespace, but we will see the function that we would use. So if we look at the first example of what would that mean, okay, that's not the first example. This would be the first example. So this is the type, and we call type off on it, so we can get it as an instance of object. And you can see it returned system type in here. I will try to make it a bit bigger.
That's what she said.
That's what she said. And so then we will use one method from the reflection namespace. It's called getMembers, which is using reflection to look at the reflection stuff. So if we call that, we will get a lot of data, and there's really a lot of it. And all of that you can use. One of those members will be the getMember method. So we can clean it up a bit. Run it again. Okay. Run it again. And then we will get more reasonable list of items that we can use. A lot of them are useful, a lot of them are not so useful. But we will highlight some of them to help us to learn the reflection stuff.
So property is there twice, one like a property or three times. Once like a getter, once the setter, and once as a property.
Yes, that's what you could see in here. If I comment this out, because that's what I'm filtering out in here in this piece of code. And you can see that we have this weird method that's called get_member_type. And this is a method that's a getter of a property, because a property on a class is nothing else than just hidden method. And then if you look at the IL, you can see that it has it's marked as a special method, and it's marked as hide by sig, which means hide it by signature. And so normally we can see it. And even if we write code that would say type.get_member, we won't be able to compile the code because it's not valid. But we can use reflection and invoke that method because it doesn't try to hide anything from us, unlike the C# code. So most of the examples that I will be showing you is something that I tried to find a real life motivation for. I should stand here because otherwise they can't see me. And the first example is something that I needed to write on a project. I had this old code base which had a very modern database that was a NoSQL database. Basically, it was just files on file system. And so they were creating objects from that file system, putting it in the server, which then sent it to the client. And this had a very bad effect because they leaked all the abstraction. And so everything was string. So prices were strings, names were strings. Well, they would be strings normally. Collections were strings, and so on. So we had this old code base full of string objects. And we need to refactor it somehow. And so we had a client and a server. And our goal was to rewrite the server first to migrate it to Entity Framework or something more reasonable. But we didn't want to touch the client because that had most of the functionality. So if we just went to an object and just said, well, this won't be string anymore, it will be an integer, then it would break all the code that we had, and we would do a lot of refactoring on every change. So what we started with was to create a copy of the old object and then automatically map it from the new object based on the property names, because renaming the property names was easy. ReSharper helped us with it, but we didn't want to change any of the functionality in the client. And I did it through reflection because the last thing I wanted to do was stick inside thing like AutoMapper and configure it for every object and fight with it, because I knew it will be much simpler if I just incrementally write it in the reflection. So that's what I will be showing in the first set of examples. Let's drink. By the way, if you have any questions, then just ask. But for most of you, it will be probably pretty obvious stuff. So let's say, well, this is my object. That's person describing me. And then I have this class called mapper, which I implemented as a static or class with a static method. And I will give you the instance that I want to map from, so my person, and I want to map it to the original object, which is person view model in this case. So that would be the simpler object that would go to the client. And so what I need to do is to go through all the properties the class has, look at each of them, and copy it to the other object. To get the properties, I can use this method that's obviously named getProperties. And it will give me a list or an array of property info object that has a lot of info on it, like is read-only, what type it has, what name it has, and so on. And the name and the type is what concerns us the most at the moment. So we will ask for the type information so we can enter the realm of reflection. Then we get the properties, save them in here. Then we do the same thing for the view model, because that one can have different properties. We don't know. And then simply we just go in a cycle through them with calling on each of the properties info a method that's called getValue. And in this case, we need to give it this instance of the original, because so far we don't really care about the instance. We are just caring about the type. If we didn't have any instance, which we don't have, like in this case, This is not an instance, that's just description of how it looks like. Then we couldn't do get value, so we need to give it some instance to work on. So instead of calling original name, we are calling property info name, get value from it, and here's your instance to get it from. So it's kind of the other way around. And that will return the value. In this case, it will return it as an object. But as long as the types are compatible, we don't really care if it's saved as an object or if it's saved as the actual type, because most of the methods here are working with object. Now then, on the view model, we can't access the properties of the view models with the property infos from the person, even though they have the same name. So we need to look at the description of the person view model and take out the same property, but it will be a different object bound to a different type. So that's what we are doing here. We are simply going through the collection of all the property descriptions, selecting the one that has the same name as the one that we are looking for, in this case, age or name. Well, age, because I don't want to confuse you with this name. That's a name of the property, not the name property on the person object. And then again, we call another method that's conveniently called setValue. We give it the instance to act on, and then we give it the value to save. And it goes like that over and over. And in the end, we map the object. And if the types are compatible, then we get a new object that has the properties of the previous object. Well, so do you see any obvious problems with that? Because I'm simplifying a lot.
So you said that you're mapping from strings to some strong type.
Yeah, I will get to that the other way around, but I will get to that through the examples. I have like 6 or 7 more of them that improve on this. So at this point, we have 2 very compatible objects that both have integers and strings and strings. So one of the problems here will be if you have a reference type, right? Because if you copy a reference type, you're just copying the reference, not the actual type. So you wouldn't be doing any cloning. You would be just copying the value or moving the reference to that value to the other type. And that's not something that I will show you how to do in this example, because it boils down to just going down the tree and copying all the primitive values in the end. So it just complicates the process a lot, but it's still the same principle. You just go through the properties, copy them from one side to the other. Now, if we look at this code here, then we are calling the map, but we need to new up this instance, which sucks because we know what we will be mapping to, but we don't really care about newing it up and putting it inside again and again and again. And so we need some mechanism to create the instance of an object. And for that, we have a class that's called Activator, and it can help us to create a new instance of an object. Plus, what I forgot to mention, this get properties and most of the other reflection stuff looks at the public instance properties or at the public instance stuff further and foremost, but you can also configure it to look at the private stuff or static stuff. And in this case, you would do that by setting binding flags in here. So the default is what? Binding flags, public, and flags instance. So you can connect them with the logical OR, and that would, put them together to say public and instance. And this is the default, but you can as well say non-public and static, and you would get different type of stuff. The same way you can ask the object for its private constructor and then call it. Or protected, how Entity Framework does it. So as I said, what we want to do is that we don't want to give it the instance anymore. We want to use the activator to create the instance for us. So we took this activator class and used it create instance method to create a new instance. Pretty simple. This is basically like calling a new on an unknown type. And then we just need to give it the type definition. So we just say type of person view model. We get the instance and we are good to go.
But in this case, I can just write a new person view model. It will be only if I.
In this case, you can, but we are progressing to more generic
Dynamic.
solution.
Okay.
So in the end, we will be mapping from T entity to T view model. And in that case, you couldn't be doing it
Yeah, and
unless you have a newable constraint on the type.
Yeah. I think it's a kind of proper solution to have new constraint.
Well, you can have it. You can also have a lot of activators that will look for the constraint and then create it from IOC container. But you don't have to tell that to all the code. Or you can look for factory or something. I don't know. This is just one way to create the object. You could new it up as well, but this is, for example, if you wanted to look for a public constructor or protected constructor, then you can't call new on it. And that's what Entity Framework would do for you.
Yeah.
So you would have to, if you looked up the protected constructor, you could call it with this, but not with new. So that's one case to use it. And then we just continue as before. So we created a new instance, put it in the VM, asked it for a type and for properties, and then we just map it. Now we are getting to the example that I talked about on the start, that we have a person that has integer as its age. And then we have the view model that has a string as its age. So we need to change the type between assigning or getting the value and setting it to the property. And for that, we can use this helpful class that's called convert. So it has a method that's called change type. And we can give it the value, and then we will give it the type that we want to cast to. So in our case, this property type will be the string because it's coming from the view model. Everybody still follows? You look bored. And so it will try to cast this, so from integer, wow, from integer to string. Okay.
So does it? How does it? Does it use internally some like a conversion operator? So if the type doesn't have a.
It uses I-convertible interface.
Okay. And it doesn't have it. If it doesn't support it, it will.
Then you will get exception that says the type must have I-convertible interface implemented, which sometimes you can get around. So for example, in one of the examples that I have, I was getting this error and then I realized I can just save it as IList. And so I don't need to do the conversion from object to list of T. I'll describe that later if I remember it. And so now we have another case. So we already learned how to map properties between objects. We learned how to create a new object. We learned how to change a type of an object, which you also might find very valuable in situations where you have incoming type of T, and you know you have another type of T like T output, and you know that the T and T output are compatible, but the framework tells you you cannot cast from T output to T because, I don't know, something. So if you use change type, you can kind of guess that it will work. And if it will work, then you are able to change it from T to T output. Sometimes it just seems like a big problem that's unsolvable. So what was I saying? Okay, so at the moment we have our person and we have password on it saved as plain text because our system is awesomely secure. And we would probably prefer if the password was empty on the destination object. And so in our system, probably we could just delete this property and just say, if you can't find it, then just don't map it. But this view model also had password. And so we want to just be able to annotate the data that we have now and say this won't be mapped, so please skip it. So for that, we created a new attribute that derives from the attribute class and called it not mapped attribute. And the convention is that you can just call it not mapped in here, or because the runtime understands that you meant not mapped attribute. It's just a small note on the property in this case that says if somebody is looking for this info, then don't map. But if nobody looks for the info, then nothing happens. And that's usually the case with attributes, unless you are doing authorize attribute in MVC that has a lot of functionality inside of it for some reason. And so we need to look for that attribute. So we need to go in our code and do some more changes. So in this case, we are looking at the properties of our model, and we are saying only use the properties that don't define the attribute. So this get custom attribute method will ask the property if it has the attribute of this type. And it also has different overloads that you can use if you want to ask for multiple attributes, or if you want to look it up on derived type, I think. That should work. But in this case, we're using the simplest one, just asking for it by type, and it will be pretty fast and will give us the answer that we need. Which just reminds me that I could run all of the examples because they actually work. So let's try to run it now. So in this case, you can see that it's too small. That we have the resulting object that has my name, has my age, and doesn't have my password. And well, if we remove the mapping, then it will still work. Ooh, how cool is that? Not so cool, right? So how many of you already written code like this? Or are you relying on the libraries?
Many not written code.
Yeah.
How many of you write it every day?
Play surprise if you want.
Play surprise?
Like we are surprised.
Okay. I didn't know we have a company full of reflection experts now. What does this show? Okay, now we are coming to the example that you talked about, that we are mapping from an unknown type to a known type. So we can't really rely on the actual types inside of our mapping code. And so what I did here is that I changed the signature of the map method and gave it two type parameters. One type parameter called tEntity, and the other one tViewModel, or it could be tFrom, t2, which would look terrible. And so now it becomes a more generic solution, so we can use it for any two types as long as they have the same properties. And we would probably need to, ignore the properties that don't exist on the second object, but that's just another if inside of this code that doesn't have to do anything with reflection.
You need the first parameter in generic person.
This one?
Yeah.
I think you do. Why wouldn't you? You can do
If I
partial.
use it without the parameter.
You can use get type.
No, it would infer.
No mapper has this parameter.
Okay, I could do that.
If you remove it,
It should infer it from the parameter from the person.
get type.
Maybe.
Yeah, it could be simple object, that original. And through get type to get type.
It could be, but then how would you know which type you are mapping from? No, you would know it in the code, but if you look at the code, it's much nicer to see. I go from this type to that
So
type.
maybe if you try to remove it, the compiler says it's okay or not.
Now, if I remove it, it will tell me that it can do partial type inference.
Then you need to switch parameters in signature, maybe then you can skip it.
You think
Yeah,
so?
Yeah.
Okay, let's do
I'm
that.
not sure.
I don't think you can do that. No, you can do partial type inference. You would have to do like
either
a
everything or nothing. Yeah.
mapper something, map person, and then another method, and then you would have to remember from the previous method. And I think that was the last time I saw it. So who knows how it works now? Now you broke my code.
You broke it.
Ooh, it still works. And not only we can map people, we can also map animals. So it works with, and other types as well. So it's reusable, awesome solution that obviously everybody here wrote at one point in their time in their lives.
Sure.
Okay, so that should be it for the first part. So as a review, as everybody knows, now as we found out, you use get properties to list properties. Yeah? Then you use get value and set value on the property info objects to get the values and set the values. Then you can use activator to create new instances on public constructors or whatever constructors you are able to find. You can even do it on static constructors of classes. And then you use get custom attribute of t to find an attribute on some member. So it could be on the type, it could be on the property or method, whatever you are able to do. It can be even attribute on the generic type parameter. That I never actually used, but it works for some reason. Oh, no. And then we can use convert change type to convert between types. So this was the boring part of the reflection. And now we will try something with generic types. So who is expert on generic types with reflection here? Nobody else? That sucks.
Just me. I'm the expert.
Cool. So first, let's start with some vocabulary because probably most of you heard about it. I just wanted to have it on the slide so we can all align on what means what. So the first thing is open generic type. That's a generic type that doesn't have any of the type parameters specified, or it could also mean the T in this definition. That would be an open generic type parameter. So this is open, this is constructed, which is like partially closed. And then there's the closed one, which we use every day for dictionaries and lists. And I don't know what you use it for. And that one we can actually instantiate, and we could feed it to our activator to create a new instance, and it would happily give us an instance of dictionary of strings and integers. So that's just so we align on the vocab. And so now in this example, that's not something that I'm doing in my project, but it was the only example that was reasonable enough that I could come up with. So let's imagine we have a situation that we have a lot of different types of objects, like we call them entities in this case. And we have a manager that says, hey, we need reports that can create tabular reports on every entity that we have in the system. And you're like, whoa, okay, that will be 6,000 controllers. Or I can take some piece of reflection and parse the incoming requests, get the types from them, create repository from it, generic. So yeah, not many people like generic repositories, but that's not the part of the discussion. And then we instantiate it through reflection, we filter it, and then we return the data to the web thingy that will give it to the JavaScript thingy that will generate the table. So for us, only the part is like query the server, parse it, get back data. Basically the same idea OData has, or GraphQL maybe, I don't know. And so first we need to generate a page where the user can actually select some data. So we want to look through all the types that we have in the system that implement entity or our entity base class. And we want to list it in what? We want to list it in a drop-down box so the management is happy. So normally the way you would do it would be probably this. You would ask the current app domain for its assemblies, and then you would select all the types from it, right? Expert? No. But for some reason, this fails in the link path. So I'm taking a shortcut and I'm taking a smaller scope. It runs for the first time, but then it fails.
No,
Maybe-
I use everywhere your second option because I usually really like to list just the assemblies I really need for the mapping. So I think it's a good idea for you to just, I use usually some kind of pivot because this way you will read even, some nuggets and
Yeah, well, it
system and
still
everything.
takes like 10 milliseconds at best to
okay, but
get
it's just
everything.
a big mess.
But, well, we are writing fast solution for our management to be happy. So we want everything, and we don't want to them knocking on our door saying, well, you missed this entity.
Whatever. Say.
We cut your bonus. So this was what I went originally, and it fails miserably in the link path on second run. So instead, I'm just taking this type of entity because I know it's defined in the same assembly. And just taking the assembly from there, and then I take all the types that reside in this assembly, which is, just this in this case. And then I need to filter it down to, well, we're taking just the public types, but we could add more parameters here to say we want even the private types, protected types, internal types, and stuff like that, but we are just going for the publics. And then we want just the types that can be converted to entity. So in reflection, you do it like, if you imagine an assignment in code and you have variable that's entity equals to something, then if you could legally put that code and it will compile, then it can be converted to entity, right? So that's what this method says and tries to do. And so we just take stuff that's derived from entity. And we
so
also,
there is no method like asking for if it's in base class or something.
you mean like this would be
I'm just asking, I don't know.
t dot is derived from type
Yeah,
of entity.
yeah.
Yeah, no. But you can write it. You can just write extension method and just put this inside and just switch the parameters.
I think I create extension exactly for this case.
I think everybody did.
Yeah. Yeah, everybody.
Everybody from the experts. Yeah, from everybody who had the hand up.
I did as well, but I just asked.
You just forgot and you wanted to tell everybody, point out my obvious mistake. And then we want to get types that we can instantiate, because if we can't instantiate them, how we can show them on the web page? And we want types that are not generic. or that are closed. We want types that are closed so we can, again, instantiate them. So an abstract type would be, well, probably none in this case, but just an abstract type would be this entity, but that would, that would still be included because we can assign entity to entity.
I think static types is abstract too.
But in this case, we are just looking for public, non-static.
but
That's the
when
default.
when you remove the is abstract, you will remove static classes as well, just like from the
Okay.
project.
Yeah, I didn't think about that, but I'm already filtering it in here with the get types. And then we don't want the generic types like this one here, which would be an event of T, which we use it to do fancy stuff like saving print events in our DB. So we want this print event, we want this dog, but we definitely don't want this one because that can be instantiated just by itself because nobody said what the T is. And we don't want this base class because that's abstract. Hate this one. So this is our first part. We looked up the types that are available and we serve them to the user somehow. And this is a useful scenario if you're implementing plugins, for example. You can just dump your DLLs into a folder, then just say from this folder, load everything that's start.dll. And from that, from those assemblies, load all the types that implement my iPlugin of the interface. And that way you can, on runtime, load your plugins. You don't have to recompile the whole solution every time you add a new report or whatever. And you do it only once on the start of the web app. So it doesn't really take that much of the performance off. But then you have a lot of stuff loaded, which you would anyway. So doesn't have that many downsides. Or you use it a lot when you register types automatically for IOC containers. So you don't have to register each type manually. You just say, just every type that I have that's public and every type by its interface. And then you just happily provide dependencies to your classes. So where did we end? So that was the first part. We listed the types that we have available, and the user has chosen and clicked post or select or whatever, and we got this request back which said the type is user query doc because LinkPath defines everything inside of user query type. And the ID that I want to filter down to is 1. So now we need to take that query, create a repository for this user query doc. That sounds really weird. And filter it down to ID 1. Normally, I don't know if you would do it like this, but I have this generic repository that's what type? Open or closed?
Open.
Good, it's open. And so the first step that I do is I take the type name and I need to convert it to a type instance in some manner. So for that, I use this getType method that will do that for me. And then I need to get the type of repository, the opened type of my repository, so I can say it's repository of dog in this case, because that's what the requirement says. And so I get an instance of type description of opened repository type. Wow, this gets unwieldy. And then I can call a method that says make generic type, which will convert my opened repository type to repository of dog. So it will close the type, and now we can create an instance from it, right? So we take this closed repository type and tell our activator to create an instance from it. And he will happily do it because we have public constructor. And then we need to call a method get on it and give it the ID. I probably didn't talk about that method, but that's what my repository implements, only method that can give it back by ID. And so we look at the type, we ask for the method in the same way we would ask for the property. And in here, I didn't want to hard code the name. I just used the name of operator. So if I decide to rename it, it will automatically fix itself in all the places that I would use it. And then we just invoke the method. So at first, we give it the instance of our repository as a first parameter, and then we give it an array that would contain the parameters for our method that would be ordered correctly. So we only have one parameter that's called ID, so it's the first one, and that's why we only have ID here. But it doesn't have a convenient overload that would just say invoke repository instance and then just with one parameter or with two parameters. You have to create the array all the time. And you don't need to specify the object in here. It would work sometimes if it can infer that it should be array of objects. But then if you mix the types, it starts complaining that it can't infer the right type of the array. So I just write it there every time. And so if we run it, we can see that we got a dog with ID 1. And if I change the request, we will go with what's the other one? Car. Now we are querying for a car with ID 2. So we, through reflections, successfully converted incoming string to actual code call and return the data, which is something that the MVC framework does for us normally. So that's pretty easy when you work with generic types. The other thing that we might want to do, and we are asked by our managers, is to order the result somehow. So in this case, we were just returning one instance of an object, but we moved on and we are returning the whole collection, and we have this option so we can order by any property on the given object. And because we didn't have any better idea, then we just decided, yeah, well, there's this queryable order by, so let's just call that. But when you look on the definition, you can, well, first see that it's an extension method. Well, you can't see it, but I can. So it is an extension method, so it actually isn't on the iQueryable collection. And then you need to provide this lambda to it, which might be a bit daunting task, but experts can do it. And so if we run it first, let's hope it works, So now we are ordering again by color. We have this request incoming. And we're just skipping the whole part of creating the collection through the repository and so on. Now we just assume we have an iQueryable of dog, which we define here. And we need to call the order by on it, which would look like this in a static code. But you can't just simply go here and just say caller, which is exactly what we want to do. So we need to build the lambda ourselves. And so first we need to build this part of the lambda, which will then eventually will become expression func of dog and string, because the color is string and dog is the entity that we are querying. So this first part is called the parameter, and we build it through expression class with its helper method parameter. We give it a type, which will be a type of dog. And then we give it some name, in this case, D, because we have it in here as well. And then we need to specify this, and this is property. So we are using, again, expression.property. First, we need to give it the parameter, so it knows this part. And then we give it the property info that we got from the type. So we are getting one object that defines the property, other one that defines the actual parameter and its type, and we're just connecting them together. And it will become basically something like this. Fine. And so now we have the two parts, the one before the fat arrow and the other one after the fat arrow, and we are ready to build our lambda expression. But as you saw, we need to make it an expression of func of dog and string. So first, we can just build a func because the expression part will be provided by the expression lambda function. And so we construct an open type of func that takes two generic parameters. And again, as in the previous example, we use make generic type to close it. And we see that we need to have it a func of dog and string. So that's exactly what we need to provide. The type of the dog that we are creating and the type of the property, in this case, string. So it will look at the color, take a type, which is string, and will create a func of dog and string. That's funky. And then we just use expression lambda, give it the type that we want to use. We give it the property that we want to insert and the parameter that we want to use. Pretty simple. So we have the lambda, but now we need to invoke it and put it inside of the order by method. And as I said, the order by method isn't method defined on the iQueryable. So we can say type of iQueryable, give me back order by, and I will just call you. Instead, it's an extension method. So we need to look up where that extension method is defined. Is there anybody who doesn't know what the extension method is? No? You? So it's a static method in a static class that acts like it's part of another object type. So we have iQueryable, which is just an interface. And then we can attach another behavior to it by using extension methods. But that method is not defined in the iQueryable interface, because interface can define the behavior. It's defined in another method, and then when you just say iQueryable collection dot order by, the compiler understands what you meant and connects them together. But instead, it converts it to call that's queryable, that's the name of the static class, dot queryable collection, and then the lambda.
Isn't it a little bit strange that you all everywhere use some abstract type, and there you have the dog type?
Which one?
The equariable.
Which one? This one?
Yeah.
That's by design. Because if you then took the dog everywhere and you would replace it with T, it would still work. I just didn't want to complicate it with more genericness. So we don't want to cast it to iQueryable of entity, because in the end, we want a collection of dogs, not collections of entities. Well, so did you understand what I said about the extension method? Okay, I can show you in the code later, probably. So that slightly complicates what we want to do. So first, we can't look at the iQueryable. We need to look at the queryable, and then we need to take out a static method instead of public instance method. So that's what we are achieving in here. And how I found out it's in the queryable, I just clicked on it in Visual Studio and pressed F12, and it put me in .peek to look at the whole definition. Or, well, if you don't have .peek, it will probably do it anyway. And so we are looking for a method that are static and public. And we could also say get method, give it the name, and give it the type parameters, which is a way to look up different overloads. But the problem is that it takes generic parameters, and one of them is the expression func of T and T, what is it, pre something, or T and T2, for example. And so you would have to create the whole type through reflection just to be able to look up the method. So the simpler way that I'm using in here is just looking for a method that's named order by and has 2 parameters because there is only one like that. Instead of taking 10 lines to build the types only to filter it down correctly. And so this will give us a static method called order by. And now we need to first make a generic method from it because we still have the types open. So we'll take the method, use our familiar make generic to close it down, and we will give it the dog and string exactly like in the previous one because it can infer it from what we give it. And then we just go invoke. A very common mistake could be to put the queryable instead of this null. But you have to remember that this is a static method. So the first parameter would be this in that context. So it would be the instance that you want to call it on, but we don't have any instance. It's static method. So we give it null. And then the first parameter, the extension, the this ike variable of something, would go here. So that's the queryable. And then the lambda to filter by. And that's it. Then we just call toList on it, get the data, and we can dump it, which is a method from the link path, if you wonder, which just sprites it to the screen. Wow. So now we are ordering on the caller. Let's try changing the request and order it on ID just to see if it works. And apparently it works because we have the ID first, ID 1 first and the 2 second. So any questions for this? Is there anything new for you?
Not really.
And for the others who are not geniuses? Okay, no questions. I don't have that much time because I need to leg it at 17:30, which is also good good thing to escape if it didn't went according to the plan. So just a few short words on performance, and I won't do the review that I have in the presentation. You can see later. One thing is that people say reflection is slow, reflection sucks, I don't want to use it, it takes too much performance out of my code and so on. So you have to measure it every time, you have to measure it. And especially if you work with software that interfaces with people and you are using it to create reports that go from before we had 30 minutes to get a report, now we have 2 seconds or 10 milliseconds because the calls that I showed you, you could see it's instantaneous. Then it doesn't really matter. And if it gives you the opportunity to learn reflection better and do a great job in 10 lines of code, then why avoid reflection? It's a tool as any other. So, but I just try to give you some measurements to see if we get a property from this cached property info object, or if we do it directly. So I just have 2 callbacks in this speedrunner testing harness, or how do you want to call it? And I'm calling it either through the get value from the reflection or directly. And I'm doing the same in here with a method and with method directly. So the first result is always the reflection. The second one is always the direct call. And on 1,000 rounds, it amounts down to 0 milliseconds. And even if I move it to ticks, which is not that reliable metrics, it still lingers somewhere at around 0 or 5 ticks, which is what, 10,000 ticks per millisecond?
Yeah.
100,000?
10,000.
It's 250 nanoseconds.
Yeah.
No, 100 nanoseconds. That would be problem. So it's pretty fast, and we are not doing something brutally hard in this. And even if you go around the whole object and synchronize it, then it might or might not suck all the performance from your program. And then if you want to go further, you can do expression, you can compile them, you can do dynamic delegates, you can do dynamic methods, you can emit code directly to dynamic methods. And that's something that we will look on next talk using this tool called Fody that takes emitting code and puts it directly in your assembly. So you don't get any of the performance hits, but still it can give you easy way to log, easy way to create toStrings for all your objects, implement iNotify property change for you, and so on. So here is just a quick.
So something like PostSharp.
It is like PostSharp, but it's free.
PostSharp is technically free too, but the library is
On Friday, I think, or on Monday. They have one day when it's free already. Yeah.
Technically.
Yeah, it's technically free, but
Some features are free. some
when
are-
you some
Well, I will have to run, so you can discuss it out
Okay.
when I leave. And then you can have as many questions as you want. No, but I find it really interesting too, and it gives you the power of what you probably wouldn't be able to write yourself, and you can do it very easily with just adding few attributes and stuff like that. So this is how it works in very small scale. So we are creating a new dynamic method. You can see that we are not attaching it to any module. Module, just think about it as an assembly, so any assembly. And you don't have to name it because you won't be able to call it by name anyway, but why not? And this is taken from a Microsoft article on the web. But what it does, it takes a number and squares it, something that we can do, like this. But we can also write it in the IL code, which all the code compiles to. And at first sight, it might look very, very difficult to understand. But the whole CLR is just stack-based. So you have this stack, the thing that you put something in, and then it will pop out as the first thing. And so what this does, it basically just says, take the first argument of this method and put it on the stack. So you have it here. So in our case, it would be 1, 2, 3 that we want to square. And then we say, OK, the output would be better as long, not as integer that we got inside, because we would get overflow. So we want to convert it to integer, which would be int64, which we have an opcode that's conf i8. Super convenient. And then either you could replicate those two steps and load it again, or you say opcode dup, which is duplicate, and you take the thing that's on the top of the stack and you copy it and push another one. So then you have 1, 2, 3, 1, 2, 3 on the stack. Now you say multiply. This operation code takes two parameters, or well, two values. And so it pops two values from the stack. So it does pop, pop. We have nothing on the stack. And he has 1, 2, 3 and 1, 2, 3 to multiply. So he multiplies it. That's something like 15,000 something. And returns the value by pushing it inside of the stack. And so then we have the 15,000 value on our stack. That's what we wanted. And so we just say return. We pop the value that's on the top and push it to the function that called us. That's how the whole .NET works, actually. So it's not that complicated. And if you look at this, I at first thought, well, that's like assembler, but you don't have to learn all the registers, how to use it, and so on. You just have evaluation stack, and that's it. And well, there's a lot of rules, but one of the rules is do not leave anything on the stack when you're leaving the function. And then when you look inside of the actual emitted code, you can, with the basic knowledge of some of the basic opcodes, you can understand what's happening sometimes. Okay, in very basic cases. But this is what a lot of the tools do internally, and you can see it in their own code. So it might be good to understand at least a bit of it and what the mechanism on the behind is, because this will run without no performance cost, and we can do it dynamically. And that's what the Foddy library does, and that's what we will have look on the next time. And maybe after that, we might look a bit closer on the IL itself, if I learn it in the meantime. So that's all from me, and I will send you the presentation and all the code samples if you're interested. Well, I did it quite on time. And now I have to go. So thanks.